How many times have you happened to admire the moon in the sky during a beautiful clear night? The moon is the only natural satellite of the Earth, from which it is on average just under 400,000 kilometers away, or just under 2 light seconds. This means that if we could travel from the Earth to the moon aboard the Millennium Falcon from Star Wars, and the speed of light in a vacuum is equal to 300,000 kilometers per second, it would take us about 2 seconds to reach our satellite. The moon travels an elliptical orbit around the Earth, so its distance from us is variable. If we could superimpose the moon on the Earth, we would find that its diameter, 3,470 kilometers, 1/4 of the Earth's diameter, would lie comfortably above the United States of America from the East Coast to the West Coast. Observing the moon, even casually, you will certainly have realized that it has a changing aspect, evening after evening, due to the phases. But why does the moon have phases? They are due to the reciprocal position between the sun, the Earth, and the moon. Since our satellite travels its orbit around our planet in about a month, the effect of this movement is that, to us, from the Earth, it seems that the moon moves through the celestial vault. Observing the moon carefully, we will be able to see how evening after evening, it rises 48 minutes later than the previous evening, and appears to retrograde towards the east. Obviously, sunlight always illuminates half of the lunar globe, but we on Earth, due to this apparent movement of the moon across the celestial vault, see a different portion of the lunar surface that is illuminated by sunlight from one evening to the next. Let's see now what the main moon phases are. New moon occurs when the moon is between the sun and the Earth. It is said that the moon is in conjunction with the sun. Being on the opposite side with respect to the nocturnal hemisphere of the Earth, the moon in the new phase is not observable. This is true unless there is a total eclipse of the sun, which occurs when the Earth, moon, and sun are exactly aligned on the line of the nodes. Remember that the line of nodes is the intersection between the planes of the Earth and lunar orbits. Waxing moon, between the phases of the full moon and the first quarter. The moon has the appearance of a sickle, with the convexity of an illuminated part facing west towards the sun, basically towards the right, and the concavity facing east. Just after the new moon phase, this sickle is very thin, but as the days go by, the crescent moon progressively widens up to the first quarter phase. The crescent moon can be observed in the early part of the night. About 3 days after the new moon, we can clearly see the sickle that forms the illuminated portion of the moon, accompanied by a weak light diffused on the remaining part of the disk, which allows us to distinguish all the rest of the disk from the sky background. This faint glow is called ashy light, and is due to the Earth's reflection of sunlight in space. First quarter occurs when the moon is at 90 degrees with respect to the joining line between Earth and sun, hence the name quadrature. From the Earth, we see that the right half of the moon is illuminated, while the left half is dark. It can be observed in the first part of the astronomical night after sunset. Remember that the beginning of the astronomical night by convention is fixed when the sun is 18 degrees below the horizon. Waxing gibbous, between the first quarter and full moon phases. The illuminated part of the moon takes on an oval shape and increases in brightness for the following 7 or 8 days, until it reaches the full moon phase. Full moon occurs when the Earth is between the moon and the sun, being on the same side of the night hemisphere as the Earth. The full moon has a circular shape and is visible during all night, because its hemisphere, illuminated from sunlight, faces the terrestrial night hemisphere. Since it is on the opposite side with respect to the sun, it is said to be in opposition to the sun. It passes through the meridian, i.e. it reaches its maximum height on the local horizon at local midnight and sets when the sun rises. Waning gibbous, between the phases of the full moon and the last quarter. The illuminated part of the moon again assumes an oval shape, but with the convexity facing in the opposite direction compared to what happened for the phase of growing gibbous. Its splendor diminishes. The waning gibbous moon is visible in the second part of the night. Last quarter Like the first quarter, it occurs when the moon is at 90 degrees with respect to the joining line between the sun and the earth, but on the opposite side with respect to the first quarter. Therefore, we from the earth, when the moon is in the phase of the last quarter, this time we see that the left half of the moon is illuminated, while the right half is dark, visible in the second part of the night. Waning moon. Between the phases of the last quarter and the new moon, the moon again has the appearance of a sickle, but with the convexity facing in the opposite direction, to the east, compared to what happens for the crescent moon. As the days go by, the waning crescent moon tapers more and more until it disappears in the new moon phase. The waning moon can be observed in the second part of the night. It is good to make an important clarification. The aspect of the moon phases described here is the one visible for the inhabitants of the northern hemisphere. In the southern hemisphere, the phases of the moon are the other way around, in the sense that during the crescent moon, the convexity of the sickle with the illuminated parts is turned to the left, while during the waning moon, the convexity of the crescent is turned to the right. As you get closer to the equator, however, the crescent moon appears shaped as a boat, that is, with the hump facing down, or as a bridge when the moon is waning. The phases of the first and last quarter are also called quadratures, while those of the new moon and the full moon are also known as syzygies, a term that derives from the Greek and means union or conjunction. A complete cycle of phases, for example between the two new moons, is repeated every synodic month, that is every 29.5 days. Because of this periodicity, the phases and aspects of the moon in ancient times gave rise to the use of measuring time by months and weeks of 7 days, a way of dividing time based on the periodic and subsequent return in the course of a month of all the phases. Because the moon every 7 days appears with a new dress. The phases of the moon therefore constituted the first measure of time. In the sky, no other phenomenon indicates such remarkable variations. In ancient times, the moon phases were used, for example, to regulate assemblies, sacrifices, public exercises. The moon was counted from the day it began to be visible. The first appearance of the crescent moon was sought with care, ascertained by the high priest and announced with the sound of trumpets. Even today, this discourse is of fundamental importance for Muslims because the end of the Ramadan fast is determined precisely by the movement in which the first thin crescent moon, Hilal, appears after the new moon. At the moment of the first sighting, the moon has an age given by the time, in hours or days, between the observation and the instant of the new moon. Trying to identify a very young sickle has become, for many amateurs, almost a challenge. The moon of one day, 24 hours, is very dim, while a moon of 18 hours is perceptible with binoculars, but is difficult to observe with the naked eye. Descending below is a difficult undertaking. The observation limit without the aid of instruments seems to be 14 hours. The first observation recorded with the naked eye of a very young moon belongs to Julius Schmidt, who in 1871 saw a sickle of 15.4 hours of age. On May 2, 1916, in Scarborough, Yorkshire, 2 English amateurs identified a moon of 14.5 hours without tools. The limit lowered on May 5, 1989, in Houston, Texas, where 2 observation groups cited a 13-hour and 24-minute sickle. With the use of telescopes or giant binoculars, the limit drops by 2 to 3 hours. On September 7, 2002, from Rashek Bala in Iran, Mohsen Ghazi Mirsaeed with giant binoculars observed an 11-hour and 42-minute sickle, surpassing a previous observation by James Stan. Then on January 20th, 1996, from Tucson, with an 8-inch telescope, he had seen a moon of 12 hours and 7 minutes. Now let's see some curiosities related to the full moon phase. Have you ever wondered what blue moon means? This is the second full moon that occurs in a month. Usually there is only one full moon in a month, but occasionally, when you are in a month of 30 or 31 days, 2 full moons can occur. The next blue moon will occur in August of 2023. Similarly, the black moon is the second new moon that can happen in a month. The next black moon will occur in April of 2022. February, on the other hand, is the only month that sometimes can host only 3 phases of the moon. While the supermoon, it is nothing other than a full moon that occurs at perigee, that is, when it is at the minimum distance from the Earth. If the moon traveled in a perfectly circular orbit around the Earth, its distance from our planet would be constant. It follows that also the apparent diameter of the moon would be the same, and therefore we would see the moon apparent diameter is always the same. Since in reality the moon does not travel in a circular but elliptical orbit in a month, it will not always be at the same distance from the Earth within a month, but at a variable distance between a minimum value, the perigee, to about 356,410 kilometers, and a maximum value, the apogee, at about 406,740 kilometers. As a consequence of the elliptical shape of the lunar orbit, the apparent diameter of the moon that we observe from the Earth will vary. At apogee, the moon will appear slightly smaller than when it is at the perigee. By dividing the difference between the apparent diameters of the moon at the perigee and at the apogee by the diameter at the perigee and multiplying by 100, we can see how the moon at the perigee appears approximately 12% larger than the moon at the apogee. With the naked eye, it is difficult to grasp the difference between the apparent dimensions of the moon at the perigee and at the apogee. But in this case, photography comes to our aid, because it is sufficient to compare two shots of the moon taken at these two moments. Many think that the best time to observe the moon is during the full moon phase. Those of you who have tried to observe it through binoculars or a telescope will soon realize that it is not so, because it is too bright, and the sunlight that arrives almost perpendicular to the lunar surface prevents us from seeing its details well. In fact, the best times for observing the moon are around the first and last quarter phases, when the sunlight is grazing to the lunar surface and clearly highlights the impact craters, especially at the terminator, the border between the dark part and the illuminated one of the moon.